All right, so you need your handout here. This will be the first soil video. And on this video here, you will have to answer those questions on the handout.
Hello ladies and gentlemen, and welcome back to another screencast by your Earth Science teacher, Mr. Stano. And today we're going to look into soil formation. If we look at this picture right here, we can see there's a number of different things in it. We have some leaves, some grass right here, and then also what appears to be some sediments. The end result of weathering and biologic activity is soil. So when we saw the leaves and the grass, that's all biologic material, or those plants could have been doing something to the soil. And we also saw sediments, and we know that sediments are the end result of weathering. So we combine them, we get soil. Soil formation, so we start with the breakdown of rock in an area, generally bedrock. And what will happen is either through chemical or physical weathering processes will break down, and we can see that right here. As it breaks down, the sediments pile up. So we can see here there's a pile up of sediments. And ultimately what's going to happen is that as these sediments are going to pile up, we have organic material also up on top, or plants growing. As the plants grow and possibly die, they'll contribute more organic material to the top. The organic, in this situation here, is once living organisms or material. We have a number of different soil horizons or soil layers. We have the O up on top, which is our organic layer containing all of our plants right here. Then we have A, our topsoil, and you can see that as we go down, the colors change a little bit. So this region right here is our topsoil, from here to here. Rotting plants, organic, and finely weathered rock. We have a B horizon. And you can see here it's mostly the same color. Little organic material, right? We're farther away from it. Partially weathered rock in this region. As we get to the C, or the regolith, we can see that it's some bedrock broken down into bigger pieces, and then finally a D horizon, which is bedrock right here. Sometimes you'll have all these layers, sometimes none. It depends on the area, but in a typical region where we have the breakdown of bedrock, and with given enough time and little disturbance, we'll get the sediments to pile up with organic material up on top. Here, this person made a cross section and marked the different horizons. So you can see here with these little T's, they marked the number of different soil layers that we have in here. Okay, as we get to the top, so we have our organic layer right here, A for topsoil, B, C, and I think the D is way down here. They're probably a couple layers off, but there's definitely distinguished differences between these. Soil types. There are two major types of soil. We have transported and residual, and pretty much the names give their soil type away. Transported soils are soils that have been carried by wind or water from location of the parent rock. So that means it weathered, broke down, and then something moved it. Most of New York soils is actually transported soil that was brought by glaciers. Once again, trucks coming in, backfilling into areas, transported soils. They're not from where it originally broke down. Then we have residual soils. This is where bedrock is broken down, sediments pile up on top, and they stay there. So when we see in residual soils, it actually has the same composition to the bedrock below, or the parent rock from which that material broke down or weathered. This is just a map of the different soils around the United States, and we're going to go into something similar like this in class. I hope you enjoyed it. That's it for weathering. Take care.
All right, so that takes care of that video. So let's talk about soil texture and fertility, okay? And as you can see here, soil texture, when we are testing soil texture, and make sure you're getting this in your notes, but anyhow, particles of the soil are classified according to the size. So we're going to classify what type of soil it is based on the sediment size, and then how much of that sediment makes up that particular soil. So that being said, sand, silt, and clay, of course, is a big part, and we will do an exercise where we will look at a chart and we will, look at if it is it a sandy loam or whatever. So we'll get into that some. But anyhow, with the sand, silt, or clay, with sand being the largest and clay being the smallest, and I keep saying that because that's something that you have to make sure that you don't forget, okay? And then, of course, the texture of the soil affects its capacity to retain moisture. Therefore, we need to make sure that we understand, is it going to retain moisture? You're going to be watching a video here in just a little bit about an event that happened in American history called the Dust Bowl. And what the farmers failed to understand was the prairie land soil was much different than the East Coast soil. And I won't spoil it for you, but they just kept plowing, because in the East Coast, if there was somewhat of a drought, you could plow down and there would be moisture that would come up, and it would, of course, add moisture to the dry soil. That doesn't work in a prairie land, okay? So the texture of the soil was much different in the prairie land than that on the East Coast. When we measure soil fertility is how well can the soil support the growth of plants. And those factors that affect it, of course, would be the availability of minerals, what type of nutrients are there, how much precipitation you get, how much organic matter is present, is it on a slope or is it in a valley, okay? And of course the pH level, which is the level of acidity. So soil texture and fertility's another thing there. So what would cause the soil to erode, okay? And you need to know that there's factors that affect soil erosion, and we're going to show you a video here. Now this video in particular, I just want you to watch it, okay? Because you're taking your notes here to the left. I don't want you to, have to try to take notes on the left and fill out questions. But what would cause the soil to erode? I'm going to play this, and you can watch this some as you're taking notes.
All over the world, farmers who have fields on hillsides have to struggle with water erosion. They clear trees to gain space so they can plant crops and graze livestock. But with the tree roots gone, there is nothing to keep the rain from washing the topsoil away. The topsoil is the most fertile layer. This process is already far advanced on Myanmar's Inla Lake. The farmers on the hillside above are losing arable land, and the lake is silting up. When the water level is low, many of the famous stilt houses can hardly be reached. And the lake dwellers are steadily losing their primary food source. The native fish can't live in the muddy waters. Several initiatives have been started on site to counter this development. One solution is to plant fast-growing trees among the crops. Another is to build terraces and small dams to hold the soil on the hillside fields. Erosion can also be a problem on more or less flat ground. If the fields are wide and there are no hedges or trees, the fertile topsoil will soon be gone with the wind. Georgia, like many other Eastern Bloc countries, has to contend with the legacy of Soviet collective agriculture. Cropland stretches away to the horizon, and winds often reach speeds of up to 60 kilometers an hour. The deeper the soil is plowed, the faster the nutrients in the soil are depleted. New kinds of machines can help. They keep soil disruption to a minimum. Trees can be planted along the field's edges as windbreaks. The world population is growing, and with it, the demand for food. More and more forests will be cleared for farming. This problem is especially acute in tropical latitudes. The rainforest floor is poor in nutrients, but rich in oxygen. That makes it unsuitable for industrial agriculture. Colombia has cleared thousands of square kilometers of rainforest to make way for palm oil plantations. Palm oil may be healthy and useful for refining cosmetics or making biofuels. But once the soil is depleted by the palm tree monocultures, the planters move on and clear more land. But there is another way. Ecological farmers plant many different crops in the same ground to help balance out soil use. All kinds of plants can grow in between the palm trees. Fertilizer can be made from byproducts of the plantation's own production. That eliminates the need to clear new land and helps preserve the forest and its biodiversity. Only if farmers care for the land they've got will there be a future for both man and beast.
Okay, so soil's very important. As you know, right now, the world population continues to grow. It's over 7.5 billion people. And I've said it once, I'll say it again. One of the major environmental issues out there is overpopulation. And so, you know, how are we going to be good stewards of the land and also produce enough food for people? Okay, so we're going to be cutting off this portion of the video because the next video is going to talk about a time called the Dust Bowl, where there were sparse resources in American history.